Good morning, everyone. Thank you for taking the opportunity to speak today. I would like to talk about KDDI's use case and development scenarios. First, I'd like to introduce our company, KDDI, and myself. KDDI is telecommunication company in Japan. It has provided mobile and fixed network services. We have about 40 million customers. Sorry, I can't. Okay, thank you. Yeah, it's too difficult. My name is Hirokazu Kariya. Previously, I had been in charge for designing the layer 3 networks. I just joined the NSO project team. My team is planning to deploy the NSO system in 2017. In this slide, I will talk about why we will introduce NSO system. We want to replace manual work into automation by NSO. There are two works we want to replace. The first work is to create configuration by engineers. Another work is to set command and configuration to network devices by operators. Next, I talk about to eliminate toil. What to eliminate is a check all by people. It's Japanese tradition, but it must be toil. This picture shows Shisakosho by railway operator, which is one of the Japanese tradition. In the picture, two railway operators are checking the rail conditions and calling it's safe, okay to go ahead. Shisakosho means watching and pointing and calling. We usually use the same way for checking the configuration before sending commands to network devices. We usually check that the spell is right or not. Even though we usually copied and paste. We think so necessary to eliminate this confirmation method. We believe that NSO systems can remove this toil. I will talk about what kind of work by using NSO. We will use NSO system for software upgrade in this year. Please look at this figure. It shows the overview of our LTE mobile backhaul network. The upper side is the mobile core network called EPC. The lower side is the access networks. The mobile core network is connected to the internet, and access network is connected to LTE base stations. The target device to software upgrade are aggregate routers of LTE base stations, this orange router. They are located between the mobile core networks and the access network. It has redundant configurations by two routers. We have over 350 pair routers. If we upgrade all of them manually, we need long time and many human resources. We usually upgrade only one pair a night. We have 2 chances in a week. it means that it takes over 3 years to complete software upgrading to all routers. It's quite a long time. I hope many more short time. This is the reason that we decided to deploy NSO system. Next, I'll talk about process of software upgrade. We upgrade once by one in service. I think many carriers use same procedures. These figures show outline the procedures. The orange arrows show traffic flow. The leftmost figure is the normal state. The first operation is to detour traffic on one side. The second operation is to software upgrade with reboot. After that, we upgrade the other side in the same way. Now all operations in this procedures are expected by manual. Operations are visually confirmation takes long time. This slide shows NSO effect. The left side shows current manual work. The right side shows automatic work by using NSO. In the current work, we confirm after every action by 2 people. In the automatic work, NSO system create config and do telnet login and set config. Confirmation after these actions become unnecessary. However, the last committed and confirmation are done by an operator. Why? We can remove manual work even though using NSO system. I will explain the reason in the next slide. This slide shows the reason is there is a barrier to automation within our company because many people still consider that the operation must confirm the quality by himself. We need to escape from the tradition because we need to make all staff to recognize that NSO is high reliable product for automation, and automated confirmation itself is reliable. So we take 2-step approach. A first step is semi-automation. The second step, full automation. In this slide, it shows first step. The difference is who decide to go ahead or not. In the first step, operator decide. In the second step, computer itself decide. This diagram shows semi-automation. Many information is displayed on OSS. For example, traffic and test scoring. The operator is monitoring the OSS while NSO is working. The operator found an error. He sent stop order to NSO immediately. In the first step, we must make sure that the NSO is high reliable product for automation. This slide is second step. This diagram shows the full automation. In this step, OSS itself detects the error and sends stop order to NSO. The operator only sends origin order to OSS. It is complete automated system. In the second step, we must make sure that automated confirmation is reliable. In this slide, I'd like to show the comparison of effort for software upgrade. As I mentioned, we have 350 router pairs. There are two works while software upgrade. One is create configuration, and another is software upgrade itself. The time of each works is shortened by using NSO. In this table shows how short it takes by using NSO. We think NSO can reduce OPEX, especially person expenses. In my presentation, I explained the reasons that deploy the NSO system. I also explained a deployment scenario. I explained the difficult barrier to automation. It is Japanese tradition. To escape this tradition, we take two-step approach. First step, semi-automation. Second step, full automation. We think NSO is very beneficial. It reduces time for creating config and operations. So it reduces OPEX. That's all my presentation. Thank you for listening to.